We know about the structure. How does that structure give it the properties that metals have? Let's look at the high melting and boiling point. Here we have our positive cations and our sea of delocalized electrons. There is a very strong electrostatic attraction between positive and negative. So we've got strong electrostatic attraction between the delocalized electrons and the metal cations. And what this creates is, it's almost like glue. This cation is attracted to the electrons in between, which those electrons are attracted to the cation. So it's a strong electrostatic attraction. And this means that metallic bond is a very strong bond. They conduct electricity. And the reason for that is because of the sea of delocalized electrons. For something to conduct electricity, there must be some form of free moving charge. In this case, we've got the electrons are able to move. So what happens when we apply a charge is the electrons will move from the negative terminal here and they'll go in the direction of the positive terminal. They're attracted to the positive side. With this free moving charge, metals are able to conduct electricity. They're good conductors of heat. And here what happens is if we apply some heat energy, the electrons will bump into the cations and also bump into the other electrons and can transfer that energy across. So the delocalized electrons are able to carry that energy and bump into other metal ions, and this just transfers the energy, because remember that heat is just energy. So you'll see here, if one of these gets energy, it will move faster and it will move then on to giving some of that energy to the next cation or to the next electron and make that one move faster. Metals are malleable and ductile, and again we can explain this with the sea of delocalized electrons. They are able to rearrange themselves to hold the cations together. So what happens if I apply force to this lattice, which again I've just got my cations which are arranged in a closely packed lattice with my sea of delocalized electrons around the outside. If I apply a force to this lattice, what will happen is these cations are just pushed across, but the electrons just rearrange themselves around the outside, so it becomes quite stable. This means that you're able to bend it, and it also means that it's ductile. And this is exactly what happens if you stretch out a metal. Those electrons will just move around the outside of the cations and rearrange themselves so that there's still the positive with the negative in between. So the sea of delocalized electrons just moves around and still holds the cations together. And they are lustrous, and the reason that they're lustrous is that the free electrons in the lattice can reflect light. And you can see here the light bounces off, hits the free electrons and is reflected, and that's what causes reflection. They're also dense, and we've already pretty much discussed this. It's because of the electrostatic attraction between the cation and the delocalized